Now, today is a very important session. Why? It might open up your eyes to something that will solve a lot of your challenges, everyday challenges. I'm going to ask you to mention any concept, including how you deal with your spouse, how you teach your child, how you do implants, how you cement a crown, how you place retraction cord, how you talk to your manager, anything. Give me some examples of a methodology, how you change the tire in your car. Okay? Give me one. Give me one. Any relation, any procedure that is difficult for you to do. Hmm. How to talk to your patients? No, I don't want your character. Something that you do every day and it's challenging. Michael. Hmm. How to talk to your patient to convince him. Halim, something challenging.
Dentistry, يعني? You
Anything.
mean in dentistry?
No. Has anything to do. You can talk about your grandmother, doesn't matter. Anything. Your car, the guy who comes, the guy who changes who puts petrol in you, anything which is challenging.
I was supposed to place an implant. Okay. Patient had expectation that I'll be placing, but I knew that later on once I opened that the implant is very loose even after second implant. Think in that way. No, like patient's expectations are too high. I don't want to place the implant right now.
Hmm.
So how to deal that situation? Now,
When the patient's expectation is higher than possibly than
yeah,
what okay. High expectation.
high expectations. The patient wanted he came for the implant. He was thoroughly prepared.
Hmm.
So when you say that yeah your bone is like that when you see here it is different. Sometimes when you go clinically something different scenario. So now we couldn't, but I don't want to. I can place implant, but
So
still
you
I
don't want to
feel
ask you also some question.
like I want to wait for one more month or for that. Now like how to explain to the patient the situation.
Okay. Patient, doctor, conversation.
Yeah.
In your work, what is something challenging? You have to tell me a challenging thing in your life. Children, wife, the guy who opens the door in your building, anything challenging. Dentistry included. Your professor from high school who slapped you. Yeah, just anything
Yeah,
challenging.
so in my profession, I do marketing for this clinic.
Hmm.
So I try to grab more patients, convince more patients about, why dental health is important, why they should visit the clinic.
Hmm.
The challenging point is that to convince them,
They don't listen.
they don't listen.
They
They
don't
think
listen.
that it's very like teeth cleaning is very, it's not that required that much. It's
Important.
not very important.
You
So
are
I have to
over.
convince them.
You are
So that's
over advertising. They think.
exactly. So they think that we want to just grab their money and we want them to come here. So that's the challenging
Trust.
part.
So basically, yeah, challenging.
Balancing between
To speak in the microphone. Welcome. Yes.
one of the challenging things is working
Yeah.
is to balance between home and clinic.
Okay. Wow, that's a tough one. All right. Any more? You said something. You said. What is challenging in your life?
In my life, it's different from the clinic when the patient is pay money because most of the patient we are working with them, they have insurance. But most the problem how you can save the patient and to keep him inside the clinic to not go outside or somewhere because when he has insurance he can go anywhere.
Anyway.
Yes, this is the most problem we have it there. And also some of them they want to finish his case direct, like kun fayakun. It's very difficult how we can do it in dental
And
because we are.
every time you don't give him what he wants, he goes like
Yes.
not what's good for him, what he believes it should be. Yes, but what is the most? All right, I'm gonna try to solve this issue today using one word, but you have to pay attention to the. So this one word is very, very, very deeper than the way it sounds. This word is relationship. Now you might say, how does it affect my screwdriver? We will come to that. Now, if you look at this object, you see a liquid, right? And if this is a bacterial containing dish, patent dish, that does not mean in this air there is no bacteria. Okay? So, first of all, what you see is not the only thing which is there. That's one part of this issue. So, the relationship between the air and this liquid that you don't see exists. That's the first point I wanted to make. The second point I wanted to make, sometimes you don't see the detail of the effect of two different relationships which can improve the, not everything which is clear and visible to you, right? For example, we will come back to this again. For example, a human eye can see up to a certain point. And as we grow older, that number will reduce. An average thing that you can see focused is 2 millimeters. Anything less than 2 millimeters, you cannot see. Guess what is the size of the hole of the screw that you will put a screwdriver inside and open? It's not 2. No, of course less. It starts from 1.2 to 1.25 if you are what, let's say, Megagen, ETK, those families, it's 1.2. Once you go to BioHorizon, Implant Direct, Zimmer, 1.25 millimeter, right? So now what does it mean? When your eyes can see 2 millimeter, what does it mean? When something you're working with it every day, the size of that is 1.2. It means whenever there is garbage inside that hole, you will not see it. And if you don't see it, it will happen what happened today. There was some dust or powder, whatever food there, and when they wanted to tighten, the screwdriver did not go all the way. When they tightened, the abutment screw fractured. We tried to remove it for 2 hours. We couldn't. Now we have to remove the whole implant. You understand how this relationship between the screwdriver and the hole is an important relationship. They have to fit. That was mechanical. Now we want to go deeper to this terminology. Now let's talk about bacterial relationship with us. The bone relationship with the surrounding could be titanium, could be zirconium, could be glazed zirconium, non-glazed zirconium, could be acrylic, could be PEEK, could be gum, could be, come on, connective tissue, could be ceramic, could be composite, could be epithelium. Yeah? So bone has a relationship with whatever it touches. And then you have the connection between two objects, they have a relationship. So everything has a relationship. This is, we are looking at now, partially mechanical relationship, partially biological relationship, and this is also biological relationship. Now, when you leave a gap, you means the company who sells you this implant. They leave a gap under the screw, abutment screw or heels, whatever. There is a gap. That gap eventually will be filled with saliva. That saliva will eventually be filled with bacteria. And because it's the oral flora, okay, which has the most oral flora bacteria that you have in your mouth. They are living here, okay? Millions of them are living here. Now, if your immunity, your sugar level, your smoking, your inflammation, and so forth, do not trigger them, okay, and the percentage of the Staphylo and Strepto are within certain percentage, they can survive with each other. But if that ratio is not balanced, the relationship between the gram-negative and the gram-positive is not the relationship, they will be upset and they will make sure the patient also will be upset, because then they start causing bone loss and so forth. Let's talk about the bone. While you're putting the implant in place, the torque you apply, 10, 20, 30, 40, 45, then you cross 45. What is that relationship between the titanium and the bone is? What is that relationship called? No, when you're putting the implant, you go 10, okay? After the 45, what is it? What is more than friction? Yeah, that's not friction anymore. When you go 50, 60, 70, when you're tightening the implant, that's not friction. What is that? Compressive load, force. So that will hurt the bone, and the bone has to somehow react by more osteoclasts, more giant cells to come and try to figure out how to solve this. Yeah. So the relationship of the force, if I tap you on your shoulder, right? You say, Suhail, thank you. But if I hurt you, you will not thank me, because that relationship. You get it? Okay. Let's go to the connections. Now, between every two objects, okay, there is a relationship. Once they touch, there is a relationship. Could be son, father, daughter. Uh, you have children, right? They married? Not yet. Anybody children married? Your children not married? Your children married? Any no, not I don't have, but you? No? Imagine your relationship with your children's spouse. There is a relationship, correct? Yes? Okay. So now let's talk about the relationship between two metal objects, whether titanium and what is the difference between these two objects in terms of composition? Are they exactly the same composition? Are they the same composition? No. Screw will be the same as titanium, but implant, no, it's not the same. They are the same family, titanium, but of course this has to be harder. The screw is always harder. So every time two objects meet, there is a relationship between them. If you are not careful, what will happen? Because it's in your hand, you are putting the implant, then you're putting the screwdriver tip, and the screw, there is a relationship. If it doesn't fit all the way, it's not a good relationship. If you tighten too much, there is a relationship. And if you tighten too little, there is a relationship. Right? Yeah? When you don't pay attention to the neck of the bone, which is cortical, and you only pay attention to the cancellous, that relationship and this relationship between the titanium implant and the bone is different. Here, the bone loves to be compressed. There, the bone hates to be. So what happens there and what happens here? Here, there is osseointegration, and there is resorption, because cortical bone doesn't like, because the relationship between cortical bone and stress is a bad relationship. So if you pay attention to this relationship as a terminology, every time you take two things, maybe one is in the mouth and you take one thing, every time two things touch, I will not. If I touch, what will happen? I started a relationship. Finished. Done. Something has started. It has to be a good relationship. So don't over torque, don't overdo. Yeah? Do every time, everything. For example, you are drilling the bone. We call it osteotomy. Right? There is a relationship between the drill and the bone. You put too much saline, all the cells are getting washed out. You put zero saline, you are heating the bone to 42 degrees. But if you go to cancellous bone and you reduce the speed to only 100 RPM and you're drilling, it's a good relationship. Why? Because you're collecting 1 gram of autogenous bone to use it around the implant, for example. See? So you made the relationship of the bone receiving autogenous bone around it, around the implant. You created a good relationship between not to have the gap, because the gap will cause the epithelium to travel, right? If you fill it with autogenous, the epithelium cannot go and make a pocket for you, right? So you improve the relationship, yeah, by reducing the speed to 100 in a cancellous area and collecting the. You understand? So if you don't know all these elements, what are the elements we are talking in implant dentistry? Temperature, speed, torque. Tell me all the elements related to implantology. Any element. Angulation, bone quality, dimension in millimeters, okay? Drill what? Shape? Shape of the drill. Speed, emergence profile, shape of the implant. Any material used anywhere. So basically, all that is relevant to the relationship that we are creating by connecting at least two objects, if not more. The second level of a relationship, now we're going deeper. You understood till now what is relationship doing to you? Now let's go deeper to the concept of relationship. The pressure in implant dentistry, whether it's between titanium and bone, whether between the screw and the hole inside, whether it's between your opposite tooth and the implant when you close, or between two implants, or between acrylic and ceramic when you bite, yeah, or when you are tightening your 6-unit bridge and one of them is not passive, when you're forcing it, that push that you're creating, that pressure on the lateral direction, all that pressure, right, has to be somehow nullified or become to zero pressure at the end. Or you place the crown and it's pushing the tooth mesially and distally slightly. All that pressure, you have to understand that is a relationship now. You created a relationship between two objects which is not passive. So now who's going to take care of that? Maybe the ceramic is going to crack, maybe the screw is going to crack, maybe the periodontal ligament will forgive you and move mesially, maybe it won't forgive you and the tooth will just move labially, whatever. So you have to pay attention now. When you talk about relationship, the pressure does not become zero by itself. You have to pay attention to the pressure. The second thing in the relationship is we do have a genetic formula that, for example, the body genetically was created to have something called, say, biologic width. The connective tissue on top of the bone is 1.5 millimeter. This is genetically in your body. So if you know those genetical factors, so every time you do something and you know those genetical numbers, then you have to respect them because the body will follow genetics. Now they say, which implant system should I use? Should I use the rough surface? Should I use the laser treated? Should I use the sandblasted? I think if our osteoblast genetically cannot recognize the difference between this surface and that surface, it doesn't make a difference. But if genetically they can recognize that this one has a salt, some kind of a salt, potassium, calcium, fluoride, and they are genetically driven towards it, then yes, then that implant is better. You understand? So if just it's a advertisement from a company that our surface is this, we have a V shape, we have this shape, that shape, I don't think you should pay attention because genetically our body does not differentiate between a V-shaped thread or a square-shaped thread genetically. The last one is quantity. There is a relationship between quantity. What does that quantity mean? Any number, whether it's in millimeter, whether it's in torque, whether it's in speed, temperature, all of these have quantities. Temperature has a number, right? It's a quantity. Pressure, humidity, torque, blood pressure, or even torque pressure. So the numbers that we deal with, why we say when you tighten, the abutment screw be below 30 Newton centimeter. Because that number, after a certain time, will make a permanent deformation in the screw, and the screw tack will break. Why we say don't cross 1200, even with saline? Because too much of vibration will kill the cells approximately up to 1 millimeter around the bone that you cut. So they will take longer time to heal. So the numbers are important. That's why when we say when you do the articulating, the teeth are moving around 100 micron, try to put your implant, if you can, 100 micron below the neighboring teeth. Why? Because that number, that quantity of movement, so if you don't know those numbers and you don't pay attention to these quantities, you will miss the relationship. Yes.
Question. Now, as you say in cutting, when you cut 1,200 speed, so the cells will die 1 millimeter around the bone.
The vibration of your drill. So if you're using a brand new drill, less the killing. The relationship, that vibration is a killing relationship to the cells who live there. Yes.
What about what do you call it? Osteodensificate the bone, brushing the bone, not cutting the bone. How the effect of that in the bone cells?
The vibration. If your drill is vibrating too much to do the osteodensification, the vibration,
Yes.
it will cause less bone, less cellular death. And if it's a smooth expansion, less cellular death. Anyway, whatever you do, whether you do densification or you cut 1 millimeter radius, will be eaten by your osteoclast in 21 days, and they will be replaced by oven fresh bone in 21 days onward. So no matter whatever you do, the bone that is touching your implant at the day of surgery will not be touching your implant after 21 days. All of them have to go. They cannot be there because the osteoclast will not allow them to be there. Maximum it will stay is 20%. Maybe because it was cortical. Very cortical, yes, they might last. But the average, type 2, type 3, type 4, those cells that are touching the implant for 1 millimeter, they are gone, totally gone, and replaced by new cells. Right. Yes. So now we talked about few concepts of relationship. I want to open your eyes to, we have a classification that comes to my mind. You might change it or add to it. I have a mechanical relationship, right? Which is screws, abutment, implant, healing, abutment, crown fitting, not fitting. All that is mechanical. You want to give me one example of mechanical relationship?
Mechanical between the screw and the implant.
Okay.
The tightening.
Okay. So you understand mechanical relationships. We have hundreds of it when we do our work, right? Then you have cellular relationship. The patient is smoking, so his artery or vein is narrow. His lymphatic drainage is active. No, it's very active because it's trying to fight. And there's a different cellular activity there versus a sprinter who's running every day and he's exercising every day. Or any other cellular relationship. You have a pocket around your implant. So cellular relationship either between the connective tissue, epithelium, bone, and between the bone and the titanium. All this is a cellular now relationship. You get it? It's not mechanical. They are living. They are trying to find a solution, whether with chronic inflammation, with pus, with whatever. They're trying to survive in that cellular atmosphere that was created by you, and then the patient continued. The emotional part, you might think, it's just when you touch the patient's. When I shake hand with my patient, it's a physical, right? Not mechanical, it's physical, but it has a emotional. That also helps a lot in creating the trust, and the patient will listen to you, and they will follow your suggestion, and they, do whatever you ask them to do. So I think all these three types of relationships are mandatory when it comes to understanding implant dentistry. All of them should be applied in daily life. Now, let us look into what relationships have more than one variable or two variables. For example, you have placed the implant in bone that is two variables, they have to find a relationship. Yeah? So the titanium, whether it is tight or loose or whatever, in that you can have mechanical, cellular, if the patient is stressed, even emotional, even in this. Then you have three variables. You have cover screw or healing abutment relationship towards implant and the implant towards the bone. So you have three objects. The gap between whether you want cover screw or healing abutment, choose one. Or eye physio, let's say. You put an eye physio, right? Inside the implant. Yeah? So you have three relationships now between the eye physio and the surrounding tissue, between the eye physio and the implant, between the implant and the bone, right? Correct? So it's three variables. Now, three relationships have to, when they tell me why this cementable with resin is not a good idea. Anyway, titanium is a foreign body, right? Resin is a foreign body. So what's the big deal? What's the problem? Why we cannot glue implant crowns with resin? We are putting Emax crown with resin. We are putting zirconia crown with resin. We are putting porcelain fused to metal crown with resin, and nobody says anything. Now suddenly, implant not allowed. What the hell? Why? Now, when you have one foreign body, which is the cement as a variable, as a relationship between the porcelain fused to metal or zircon with teeth, you have one foreign body under the gum. Now you have the whole foreign body with another foreign body, which are totally two different objects. So how many foreign bodies one cell can handle? This cell is trying to come and live with this foreign body, right? Either create a cyst or create integration, right? What is the difference between cyst and osseointegration or integration? When, huh? Yes. And the cyst is, yeah, it will make a small pouch, so the arteries cannot go and take the blood from a dirty place to the body and keep it there. It will work like BioOS, like xenograph. It doesn't really, actually, xenograph is not a cyst. Just take a normal, any cyst anywhere in the body. Yes, there is a cyst still there for 10 years. It's there and it's no, nothing is happening to you because of, you don't have fever, you don't have any problem with that. Tell me how you define a cyst. Okay, does it harm you or not? Of course it harms you. How many people have cysts and they live without being harmed? Okay. Okay. Inside your sinus, there are many cysts attached to the floor for 50, 60 years. And they are there and they are not harming you. So when you do internal sinus or lateral window sinus, do you remove the Schneiderian membrane or you leave the Schneiderian membrane and you push the Schneiderian membrane with the cyst and you put your bone and implant? What do you do? You push. So you leave the cyst as being is there. Why? Because the body created this jail like an inmate. You know inmate? What's an inmate in Arabic? Prisoner. Inside, and they made a cage. No communication. Blood cannot go, come out. Lymphatic cannot go, nothing. It's a closed, sealed cage. So back to the story here. Yeah. You familiar with periapical granuloma? Yes? 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 Say yes. You're not sure. So we have three variables. And there is a relationship between three different objects. Because I'm just trying to go deeper and deeper. When you have two cements, two foreign bodies, the body cannot understand one cell cannot understand two foreign bodies. That's why they say don't use cement around implants because already the body is trying to have it's not chronic inflammation, but there is an inflammation a permanent inflammation between titanium and the surrounding cells. There is. You cannot say it's 100% zero activity. But that inflammation is somehow tolerable by the body. We'll continue. You have abutment connection to implant, and then you have bacterial infiltrate upon chewing every time. I'll show you the video. And then you have occlusion, another variable, pushing the abutment connection, and the bacteria is getting in and out. So you have four different relationships, four different people trying to have a relationship. It's like husband, wife, and two children now. Yeah, it's different than when you're just married. Yeah, of course. Then you have five variables. You have abutment screw thread connection to implant versus bacterial infiltrate upon chewing. Then you have the pressure from the occlusion, and that has also threads. So every thread has a space for the bacteria to live inside. And then you have thousands of bacteria that can live inside that area. I will show you this video. I will talk as it's talking. So try to have 1 year for me, 1 year for that. So this is the gap between micro gap between the abutment and the actual implant, right? When you chew, there is slight movement which is pumping bacteria in when it comes to that side, and when you chew on the other side, it pushes the bacteria out. Now, every time, 500 times a day you swallow, so 500 times a day you are biting. This is beside eating, right? So imagine you're chewing food. Now what is he showing here? He's showing if you have a platform switch and you have a conical connection, the amount of space is there but much lesser. This is the non-platform switch. So this relationship or this gap between the implant and the abutment till the end is a gap, we call it a micro gap, which cannot be avoided. Maybe with Bicon implants we can, but with the existing implants in the world, we cannot. So since we don't have a solution out, we will minimize this gap. And this relationship between, is showing you more videos. He's saying micro movement. If your occlusion is not proper, it's not micro anymore. It's the macro movement. When it says elastic, that means still it's not permanent. When something breaks, it's plastic. It's not elastic. So elastic means still within the tolerance of the object. So this is the abutment, and this is the gap. So we have three variables. One is platform switch, one is internal cone, and one is the diameter of the implant itself. The wider the diameter, the less the opening. The connection, if it's conical, less movement. If there is a platform switch, also less movement. So these three elements will reduce the chance of the bacteria to get in and get out, and get in and get out. Once that happens through every day, it will find a place under the screw to have. See, that's very clear. Yeah, and the gap when you chew is 36 micron here. So which one is bigger, the bacteria or the gap? I think some people are sleeping. The bacteria bigger? Bacteria is 1 micron. Your gap is 34 micron. Who's bigger? The gap is bigger. So who will end? The bacteria can get inside? Yes, easily. It's like you have a 34 bedroom and you invite me in. You think I will not go? 34 bedrooms you have, and I need 1 bedroom. Of course I will go inside. So you have a 34 micron gap, and I am in the saliva as a bacteria. You think I will not? I'm tempted to go inside and live inside. It's a beautiful 34 bedroom waiting for me. Of course I will go. See, if you have, say, zirconia implant and zirconia parts, this will not happen. But what will happen? Fracture. So this movement actually is needed for it not to fracture. Now, with Bicon, because it's hammer, they hammer it, there is a concealed that is not a screw. It's metal to metal with Morris taper. That's a different story. Wherever there's a screw, there should be a gap for the screw to go in. That gap is moving. So there is no solution out of it. But the main problem we have is not that bone. The main problem we have, if you are saying what you're saying, is the gap between the bone and the implant wall. This is not our problem. Our problem is the gap between the abutment and the implant. That is where we have bacteria going and living there. That is causing marginal bone loss, constant smell, bad smell. The gel, whether it's gap seal, leak stop, or whatever is they're trying to build, that should minimize this gap. But we don't know till what degree, because that gap is still there. It's just we are filling it with a material that the saliva cannot go inside. And when we switched from normal implants to platform switch implants, the marginal ball became less. When we went platform switch and conical connection, again, the marginal loss became less. And when we applying this Thomas's theory, which I'm going to show you again, I showed it in the exhibition, I'll show it again, with the 4 millimeter of connective tissue, again, the marginal bone loss is. So slowly we are getting very close to minimum marginal bone loss because we are understanding this relationship. So the dental implant says, now what does this Thomas say? And thank God today Mr. Halim brought us a device which actually supports Thomas's theory, and all of you get to use it in the clinic tomorrow. All right. So what are we talking about here? We're talking about a theory which says, what can you do to make this bone loss around the neck of the implant zero? Okay? If it's not zero, at least it's less than others. Let's say his theory is zero. Let's listen to him. He says, when the implant is platform switched, that means the abutment is thinner in diameter, first thing. Second, when the abutment is leaving the implant, it should not diverge outside. It should go upward, straight or concave for 1.5 millimeter. It should, within the first 1.5 millimeter, away from the implant, it should not diverge. It should either converge or go straight up. And if you have zirconia here, it should not be glazed. Why? Because connective tissue, they don't like to adhere to smooth surfaces. They like zirconia, but the glaze on the surface of zirconia will make the connective tissue find another place because the epithelium will travel to the smooth surface. So you paid attention to the 1.5, but you forgot the glazing, then you did not follow the. You remember we said genetically there is a relationship, genetic. This is genetic. You cannot change this rule. Your genetic connective tissue will always find 1.5 millimeter to adhere to anything above the bone. Yes? Yes? 1.5 millimeter. Okay. So this 1.5 millimeter seems to be little important, little sacred, little you need to pay attention to. Like your first wife. No, didn't click. Okay. So this 1.5 millimeter should never get out, should never be glazed. Now, because you want the connective tissue to stick. Once the connective tissue for 1.5 millimeter is not disturbed and it gets glued to this area, then why the bone should go away? Doesn't go away. But how you guarantee that this area is covered by connective tissue is, forget Gargiulo 1961 when he said the biologic width is 3 millimeter. Thomas comes and says for implant it is 4 millimeter. So he's changing the number from 3 to 4. If it's 4 genetically, because we didn't know this before implants, now we know after 50 years of doing implants, right? So he says always make sure you don't calculate where you place the implant, 0.5 millimeter below the bone or 1 millimeter. Don't listen to Suhail. He says go 0.75. Don't listen to him. Listen to me. Thomas says, listen to me. See where is the gum? Go 4 millimeter and place the implant. Everything else will fall in place. Sometimes you have an elevated bone level between the two teeth. Don't calculate that. Calculate the gum, and we will see practically what does that mean. So, for example, here, right, we had an issue with this patient because the lab. This is not my crown, but still, I'm trying to fix the problem. The lab sent. See, they didn't respect the 1.5 millimeter. We want from the bone level 1.5 millimeter, not divergent, either straight or convergent. Since the lab cannot get the idea, so what we do, عصفورين بحجر, we remove the glaze, at the same time we make it concave. So once it's concave, the burr, and then we can polish it. We have ceramic polishers, not glaze, polish. Not glaze, polish. We have a polisher. We can polish ceramic. Not difficult. Glaze is the problem. So when the lab send, you might say, how many times I'm going to do it? Once you keep sending it 2-3 times, and you call the lab, again you send glaze, slowly they will learn the culture. Till today, the labs has, still I'm sending back, and still they're sending glaze. I'm sending, they're sending glaze. It will take some time for this culture of zero bone loss to take place. But once you have that, you will not see the whitening of the pressure of the gingiva. And at the same time, you will always have this beautiful surrounding. I'll turn on the lights for you to understand what did I contribute to this theory. So what I did, I made a plastic 4 millimeter height cuff. You take your drill, first drill, or second, doesn't matter. You calculate the bone, and you put a line before you open. Okay, I'll tell you the problem and then I'll dance. The problem is, once you open the gum and you want to drill, you have no reference for the gum. So you look at the bone and you say, 1 millimeter below the bone, or half a millimeter below the bone, or at the bone. We don't want the bone. We want the gum. But you open the gum. So you have no reference. So you take the CEJ of the next tooth and you make a black line. Right? And then you open the gum. Yeah? And then you have a 4 millimeter. How you pass 2 and 4? Pass this on for the people who haven't seen it. So this is a 4 millimeter cuff height plastic instrument, right? So you calculate with your CBCT where is the implant, and you have a line on the next tooth, and the gum is open. You drill, the base of this will be touching the bone, and the top of this will match that line. So you are always 4 millimeter below the gum. Finished. This is my contribution to the Thomas theory. So this plastic thing is available, and now what did this was my contribution. What is the ETK company contribution to this idea? What they did, because the neck of the bone should not compress the implant. Correct? So what they did, when you place the implant, they have a screw which can be placed inside the implant before the cover screw, before the healing. And they made a gingival former, a drill, which stops and only makes platform and only makes the neck of your bone not stressing the neck of the implant. So the relationship between that cortical bone and titanium is passive, not compressive. So pass this on and try to understand. Of course, this is ideal for eye physio. Neck of the implant is supporting this Thomas theory, which is zero bone loss theory, which says cortical bone should not be compressed. If you want to read more, there is another article by Shukran, who invented this machine, the PRF machine. He also has articles on compress the cancellous bone, don't compress the cortical bone, because they resorb. Yeah? Okay, I don't want to distract you. I'll just ask you something Shukran asked me. He says, don't compress the cortical bone. Compress the cancellous bone. His question is, What do you do with grafted bone? You compress or not? Compress. People in favor of compress, raise your hand. One. Augmented bone. Just raise or not raise. Don't maybe and only one person say compress. Compress, compress, compress. Okay, thank you. Augmented bone has zero elasticity. Zero. If cortical bone has 1% and cancellous has 100%, augmented bone has zero. So it's even worse than. So never, don't even, yeah, any compression because they're almost dead. It's trying to turn over, but most of it's still not. So never try. But there is a issue I have to clarify. Maybe he's talking at the time of placement. At the time of placement, it's loose. You can compress or not compress. I'm talking about afterwards. Afterwards, they are not to be pushed. That's why when you have a block graft, never try to even reach 40 or 35. Because that block graft, which you placed 6 months ago, as soon as you go 30, 35, tuck, the whole buccal bone is in your hand. They are not ready to be compressed at all, worse than cortical. At least cortical will give you a little crack or get angry with you. This one will just divorce 100% بالثلاثة. They leave and they never, no way to put them back. Khalas, gone. Implant carriers in some companies are smarter than others. For example, you go to Spain, the most used implant system in Spain is BTI. They do like this in front of the factory and they go. But their carrier has no information, nothing, not even a dot. You know where is the buckle, where is the nothing, no marking, nothing. With the ETK, with I'm not sure with BioHorizon, Zimmer, I don't know, but most of the new companies, their carrier has so much information. Where is the 4 millimeter? Is there. So you know when you're tightening, you can relate that 4 millimeter to the CEJ of the next tooth. You get it? But if your eyes is open enough to know this 4 millimeter, to look for it. Otherwise, you keep going till you have 35 and you stop. That means you didn't pay attention to the 4 millimeter. You paid attention to the torque. Again, the relationship between the thick phenotype, okay? You remember we said there was a word of quantity. Quantity. Now, when you have a thick phenotype, thick gum on the buccal wall of the implant, the quantity of the arteries, okay, are more. Yes or no? More arteries because it's thicker gum. That when it's more than 2 millimeter or from 2 millimeter plus, that quantity of arteries, the cells that live there that take food, the arteries are taking food to the cells. Yeah, to the tell me the cells that live there. Connective tissue, osteoblasts underneath. I'm talking about the soft tissue itself, the connective tissue, the fibroblasts and all. So this food that this artery is carrying to give them, when they are more food, they can stabilize the bone underneath. They won't disappear. They won't leave. It's like a factory that doesn't go bankrupt. So if you can create a thick phenotype at the time of uncovery, you create enough quantity of soft tissue, yeah, so that they will last for many years, like your company. It will last for many years because the quantity of the people who are working inside is enough to survive. Yeah. So whenever you make this uncovery, pay attention. Don't just uncover the implant for the sake of seeing where it is. Uncover the implant thinking, I want to create a thick phenotype because I want the quantity of that soft tissue to be 2 millimeter. How can I make the buccal soft tissue 2 millimeter at the time of uncovery? This is the time, this is how you do uncovery. Most of you take a blade and cut the gum, look for the implant, you find the implant, celebrate. No, you missed the whole purpose of the uncovery, which is created 2 millimeter buccal gingiva during uncovery. So the steps of uncovery, again, could be that whenever you see a gray area, quickly cut it to get to the uncovery. Whereas the smart thing is, okay, because it's thin, the worst thing to do is actually cut here. It's not the best thing to do. It's against you to, when you see gray, so you have to go 2 millimeter palatal and make a sectional or partial thickness uncovery to bring that to the buccal wall, and then that is a proper uncovery. Now, some of us will bring the soft tissue buccally, some of us will bring it lingually and cut it in half and try to make papilla. The point is, if you plan it right, you can create a soft tissue. Now, using a punch is not for the sake of removing the gum, it's to sake of the cleaning that tags which is attached. So never use a punch to remove the gum. Use the punch to clean the area after you open the gum. So because the uncovery was done in a wrong way for the front implant, was done the opposite way. See, instead of bringing this here, it was done bringing this here. All this soft tissue made a papilla from mesial distal, but it didn't improve the quality of the buccal soft tissue. I think that's the one right there. All right. So the incision line in your calculation, this we divided the soft tissue to make two papillas either way, but we missed the point of I want 2 millimeter of buccal gingiva. The papilla can be one advantage, but the buccal gingiva 2 millimeter is the main reason why we want to make a proper uncovery. Here we did that procedure from lingual properly. Here we did the opposite by mistake. We both got papilla, but here we got the buccal thickness. Here we lost the buccal thickness. End of the day, this thick gum as a quantity has more blood supply to the underlying area, and that's what quantifies the zero bone loss theory, which is creating a good soft tissue, thick soft tissue, attached soft tissue back to the uncovery. There are times where there is bone on top of the implant. You can locate it by using a straight probe, whatever. Keep it there, take an x-ray. Don't move your hand till you're sure you see the x-ray, and then remove the bone. Don't remove the cover screw while you're removing the bone, because your burr might touch the neck of the implant and you damage. When the cover screw is there, somehow it's protecting the implant from getting. Now, why I'm showing you these numbers? Because these numbers are related to vitamin D many times. So sometimes the patient comes with, I don't have 48. When we say 48, suddenly everybody panics. Suhail, they call me, it's 48, what to do? The principle is clear. If there is buccal bone, we can try to do progressive loading or vitamin D. If there is no buccal bone, don't waste your time. 48, no buccal bone, don't waste your time. This implant is not going to work. Remove it, go palatal, go mesial, go distal, go somewhere else. This is not going to work. If there is no buccal bone at all and the number is 48, it does not work. If there is buccal bone and the number is low, you can do two things. One is, what is your weight? 95. You double the weight, which is 95 double becomes 190. So 19 drops every day for 2 weeks. Vitamin D, that will be enough for this number to go up if there is buccal bone. If that is not working, then you put a healing abutment out of occlusion, ask the patient to have food on it, soft diet on it. That's progressive loading. Slowly the number will either this way or both. You double the weight and the vitamin D and give him a healing together. Check him in 2 weeks, check him in. If the number is increasing, means that little buccal bone, what's happening to it? The density of that buccal bone is increasing. And that's it. Once you have that, the dense buccal bone is the number is increasing. Now, what will happen, hopefully, in your generation before you graduate, is we stop doing this. So, if we stop doing this, what are we doing? If this is not 2025, this is not up to date. What's the alternative? Customized. We have if we are using ETK, then we have the iPhysio. If we are not using ETK, we have the saucer shape profile making. We can use composite. We can take a abutment, thigh-base abutment, and fabricate this gingiva and give yourself something worth being proud of.